Hello, let's introduce the printing process. The fourth part of this course. Test printing process. Item 3. Ink-water balance adjustment. You all know that ink-water balance is a key point in offset printing. It is also the main feature that distinguishes offset printing from other printing methods. In the offset printing process, the adjustment of ink-water balance is very important. It is also a difficulty in the printing operation. Therefore, being able to better grasp the working principle of ink-water balance and find the problem, then find a reasonable way to adjust the ink-water balance, seems very important. The main content of this course includes the following three aspects. First, the relationship between oil and water in printing. Second, the meaning of ink-water balance. Third, the adjustment method of ink-water balance. So let's start with this. Let's take a look at the relationship between oil and water in printing. Let's introduce it first. The basic principle of oil-water immiscibility. In daily life, everyone understands the principle of like dissolves like. It refers to substances with similar chemical structures, compatible with each other, such as benzene and toluene. Their chemical structures are very similar. Therefore, they can be mutually soluble. At the same time, substances with similar molecular polarities also dissolve each other. Like water and alcohol, they are all polar substances. So these two substances can also be mutually soluble. Let's first take a look at water in offset printing. Its chemical structure and its surface tension, as shown in the picture. This is the chemical structure of water. It's made up of 2 hydrogen ions and 1 oxygen ion. From this structural perspective, water molecules are polar molecules, and it exhibits strong polarity. Forces between water molecules, made of van der forces and hydrogen bonds. The force between them is greater. At room temperature, the surface tension of water can reach 7.2 times 10 to the power of -2 newtons per meter. Let's take a look at the chemical structure of the oil again, and its surface tension. Oil is a general term for organic compounds. In general, they are basically non-polar molecules. However, the introduction of hydroxyl, hydrocarbon, amino groups, etc., also results in a certain degree of polarity. Let's take a look at the diagram below. This is the chemical structure of an oil molecule. From the left part, we see that it is a lipophilic group, and from the right part, we can see that it is a hydrophilic group. And generally speaking, lipophilic groups exhibit non-polarity. In such a group, the longer the carbon chain, the stronger the non-polarity. The hydrophilic group on the right exhibits polarity. Therefore, for most oils, they are predominantly non-polar chemical structures. However, there is a coloring scattering force between non-polar molecules. The forces between molecules are also relatively small. So in general, the surface tension of oil is less than that of water. So according to the principle of like dissolves like, and the molecular structures of oil and water, naturally, it can be proven theoretically and practically that oil and water do not mix. This is also the theoretical basis for the coexistence of oil and water on the same printing plate surface in offset printing. Let's take a look. On the surface of the printing plate, graphic and non-graphic parts, almost on the same plane. However, due to the dissimilarity between water and oil, it allows them to be clearly distinguished. Let's take a look at the printing process. What is the state of oil and water? First, we can divide the offset printing process into 2 cases. The first scenario, offset lithography is very slow. So after the water and ink come into contact, due to their incompatibility with each other, under pressure, they exist in each other's solution in the form of tiny droplets. However, if the printing speed is relatively slow, then after the printing pressure disappears, water in the ink will precipitate out. the ink forms tiny droplets on the surface. The same phenomenon occurs with ink in water. Then in such a process, the printing will fail because of water droplets or ink droplets on the surface will affect the next printing process. What's more, modern printing is a process of high speed and high pressure. In such a situation, can the mutual exclusion of oil and water really achieve printing smoothly? Well, the answer is obviously no. Therefore, in the modern high-speed and high-pressure offset printing process, we must form a relatively stable situation. And this stable situation means after a certain substance enters another substance, can form a stable situation in each other, rather than, as we mentioned earlier, a substance precipitates immediately in the form of tiny droplets that adhere to the surface. Therefore, during the printing process, our state is dynamic, and it's changing, so we need to achieve a special state. This state is called the emulsified state. The manifestation of emulsification is a droplet in the form of tiny beads of liquid, dispersed in liquids that are incompatible with it. That's a process we call emulsification. The resulting stable mixed system, we call it an emulsion. So in the process of lithographic offset printing, it must emulsify. Otherwise, a droplet will precipitate in another liquid, forming a layered interface. This in turn affects the smooth progress of printing. The stable emulsification system is also divided into two types, like oil and water. Forming a stable emulsion could be water in oil. It also could be oil in water. But in the process of offset printing, if an oil in water system is formed, the ink will go into the water. That is, in actual printing, the ink takes the form of tiny droplets, access to the water supply system, or enter the blank part of the plate surface. This will cause the blank part of the print to be stained with ink. We call this type of printing failure smearing. Therefore, after the above analysis, we believe that in the offset printing process, a steady state of water in oil must be formed. In this case, offset printing can proceed smoothly. Then, if it needs to be formed, a steady state of water in oil, during the offset printing process, it is necessary to properly control the ratio of oil and water. There are many factors that affect emulsification in offset printing. The first is the effect of paper on emulsification. The most common types of paper used in offset printing are coated and uncoated paper. Paints and adhesives for these two kinds of paper are all contain surfactants, and these surfactants will have a certain impact on emulsification. Second, the ink factor will also affect the emulsification. Due to the use of hydrophilic pigments in inks, or binders and free fatty acids, the drying agent and diluent in the ink will also have a certain impact on emulsification. Third, effect of fountain solution on emulsification. The concentration and pH value of the fountain solution, the content of the colloid and its dosage, will also affect emulsification. Therefore, in printing, we must reasonably control the concentration of the fountain solution, pH value and its dosage, reach a steady state of emulsification. Simultaneous environmental factors, such as temperature and humidity, and the speed of the printing press, the pressure during the printing process, these other factors, will also have a certain impact on emulsification. Anyway, throughout the printing process, the materials used and the environment all play a certain role in the emulsification of ink. Therefore, during the printing operation, we need to standardize the printing materials, the printing environment, and the methods of operation, making the emulsification of the ink stable. This results in higher quality prints. So let's talk about that. Adjustment of ink-water balance. To achieve a static and stable ink-water balance, let's look at the plate. Surface tension of water and ink. Their specifics. when the surface tension of water is greater than the surface tension of ink. The ink will expand into the blank part of the plate. And when the surface tension of water less than the surface tension of the ink, water extends to the graphic part of the printing plate. Only when the surface tension of the two is relatively consistent, there will be a strict dividing line between water and ink. At this time, the balance of ink and water can be successfully achieved. However, during the printing process, it's a dynamic process. Let's take a look at the printing process. 4 states of formation of water and ink. The water roller and ink roller will contact the graphic part and the non-graphic part of the printing plate, respectively. Therefore, the following 4 states are formed. First, the dampening roller makes contact with the blank areas of the printing plate, forming a nib. The second, the dampening roller makes contact with the graphic areas of the printing plate, forming a nib. In this case, water on the dampening roller will contact the remaining ink layer on the graphic part of the printing plate. Emulsification occurs. And the next 2 are: the inking roller contacts the blank areas and the image or text areas of the printing plate, respectively, forming nibs. In both cases, the ink on the inking roller also comes into contact with the water layer on the blank areas of the printing plate, and the emulsified ink on the image or text areas of the plate. Further emulsification also occurs. So in such a dynamic equilibrium process, in the last 3 cases, emulsification has occurred. Therefore, it is necessary to ensure the smooth progress of printing. In these 3 cases, we all only allow existence of water in oil emulsification system, and firmly not allowed emergence of oil in water emulsification system. Therefore, in the process of offset printing, it is necessary to achieve ink-water balance. It must operate at a certain printing speed and pressure. Adjust the supply of fountain solution, forming a slight water in oil emulsification. Use the least amount of fountain solution against the ink on the printing plate. Then, ink-water balance will be obtained. A lot of experimentation and experience shows that the graphic part of the printing plate, the thickness of the ink layer needs to be controlled at 2 to 3 microns. Water film thickness of blank part should be controlled to 0.5 to 1 micron. When reaching such a state, the volume percentage of fountain solution contained in the ink is 15% to 26%. And in such a state, in order to better achieve a dynamic ink-water balance state, here we need to emphasize that in the process of high-speed and high-pressure lithographic offset printing, the ink-water balance is a dynamic balance rather than a static equilibrium. In the process, the content of water should be controlled within a certain range. If you go beyond such a range, quantitative change will lead to qualitative change. So in the process of offset printing, the control of fountain solution is particularly important. It is one of the key points of ink-water balance. Let's take a look. Printing quality defects caused by ink-water imbalance. This is a sample print caused by ink-water imbalance. Let's take a look. The yellow plate obviously shows an imbalance of ink and water. And the blank part of the plate, the area where the ink should not be printed, is printed with yellow ink. And we think this is a print quality defect. Call it tinting. It is caused by the imbalance of ink and water, mainly because the water control is not done well. The supply is relatively high. In the process of offset lithography, to achieve ink-water balance, we should make reasonable adjustments. The first is pre-press preconditioning. We need to observe the distribution of the graphics on the plate. The larger the graphic area of the printing plate, the more water you use. Conversely, it will be less. The reason is that the larger the area of the graphic part, the greater the amount of ink. This requires more water to participate in the emulsification of the ink. So the more water you use. Second, the smoother the paper is, the less the amount of water. Third, in CMYK for color printing progress, the amount of water used for the black plate should be small, not large. Fourth, in gold and silver ink printing, the proportion of water should not be too large. Fifth, in high-speed printing, with high ambient temperature, water consumption should be small rather than large, except for pre-press. During the printing process, we should also pay attention to the control of ink-water balance. First, we need to keep the plates clean and maintain it. Before printing, we need to wash the plates with water to remove the protective film from the surface of the new printing plate. And when the printing is interrupted midway, protective glue needs to be applied to protect non-graphic parts. And the longer the downtime, the flatter the glue is. Otherwise, the non-graphic part of the printing plate will be damaged, particularly the upper sand-like layer. Second, in printing process, it is important to pay attention to the amount of water on the plate. Identification and control of water volume is the primary factor for ink-water balance. We need to estimate the amount of water based on the reflectivity of the printing plate. In general, when ink and water are balanced, the plate surface has a faint brightness. If the surface of the plate is dark gray, there is no sense of reflectivity. It indicates that the amount of water on the surface of the printing plate is too low. If the reflectivity on the surface of the printing plate is very evident, it feels watery. It indicates that the amount of water on the printing plate is too high. The strength of the reflectivity of the printing plate is influenced by factors such as machine side lighting, front lighting, and printing speed. Therefore, during the printing process, we need to carefully observe the amount of water on the plate to determine the fountain solution supply to successfully achieve ink-water balance. Certainly, judging the amount of water can also be determined according to the printed samples. If the ink color on the printed sample is light. Moreover, if the ink color remains light after adding more ink, it indicates that there is too much water. If the printed product is dull, has mottling, or the paper is not aligned, and if the sheets are curling, it indicates that the amount of water on the printing plate may also be too high. In addition, on the ink roller and in the ink tank, or impression cylinder, blanket cylinder, there are water droplets in the dragging part. This is also a typical feature of water abundance. At the same time, in printing, we can also assess and control the amount of water based on the dirtiness of the printing plate. During the printing process, operators often control the amount of water to a smaller size. If you don't pay attention, it will be scumming. Usually this kind of scumming, if noticeable at both ends of the plate, on the non-graphic part, the amount of water is too small. If it occurs at the gripper area of the plate, it means that the water volume is small. If it occurs in the graphic area of the plate, the halftone dots are blurred. When it first appeared, it meant that the amount of water was small. When the amount of water is found to decrease, careful handling is essential. Do not directly increase the amount of water. In order to avoid printing quality problems, avoid repeated adjustments. If scumming appears, usually dip a sponge in some water first. Drizzle on the water transfer roller or dampening roller. Rotate the curvature of the water transfer roller as appropriate, or increase the speed of the water transfer roller to achieve adjustment of water supply. In general, during the offset printing operation, we can learn from practical experience to control the ink-water balance. There is a saying, first look, then listen, and finally touch. The first step, look, means observing the changes in halftone dots with the naked eye or a magnifying glass. Check whether the halftone dots are clear, whether the edges of the halftone dots are smooth. When the ink water is out of balance, most dots are not very clear. Solid patterns often appear fuzzy or have spikes. When scraping ink from the ink vibrator, or lifting ink from the ink tray with an ink knife, observe the stringing of the ink in the tray. When the ink-water balance is off, the filament of the ink is often short. The next step is to listen. One is to listen to the sound of the ink roller when the machine is running. If the ink roller makes a squeaking sound while running, indicates that there is too much ink on the ink roller. You can use an ink knife to scrape off the ink from the surface of the ink vibrator for testing. If it cannot be applied smoothly to the surface of the printing plate, we can prove that the ink water is out of balance. In addition, any offset press with serious ink emulsification, the printing pressure varies. When the paper peels off the blanket, there will be abnormal noise. And touch means to touch the solid color blocks of the print with your hands, or halftone dots with an coverage of 70% or more. If you feel sticky in these places, then it needs to be noted. In addition, touch the dampening roller and inking roller with your finger after stopping the machine. Feel if the dampening roller is wet, or whether the ink roller is getting fat. In addition to this, you can also touch the surface of the plate and blanket with your hands. When piling on plates and blankets, it also shows that the ink cannot transfer well. There may be an ink-water imbalance. When the ink imbalance is serious, then decisive measures should be taken. Clean ink roller. Change the ink. Restart printing. So in order to better achieve ink-water balance, we will discuss various aspects such as technology, materials, and equipment. Take reasonable measures. The first is the technological measures. In the process, we must emphasize standardized operation in the process of offset lithography. So-called normalized operations generally refers to the 3 flat 3 smalls and 3 diligence. 3 flat refer to the levelness of the cylinder, inking roller, and dampening roller. 3 smalls refer to low pressure, low ink volume, and low water volume. 3 diligence refer to frequently checking the printed samples, frequently cleaning the ink tray, and frequently washing the blanket. At the same time, we also need to consider comprehensively materials throughout the printing process, including paper, ink, dampening solution, and so on, so that they can match each other and coordinate with each other. At the same time, we need to achieve comprehensive quality control throughout the entire printing process, including pre-press, during printing, and post-press, and fully implement digitalization. Standardize and standardized quality management. The second is measures in printing materials. In the offset printing process, in order to achieve better ink-water balance, we need to choose and use printing materials that are conducive to achieving the best ink-water balance to meet the requirements of printability. Therefore, we must conduct strict testing and approval for paper, ink, and dampening solution used in the printing process. By predicting beforehand, on the one hand, this allows us to be well informed before printing, to take appropriate process measures. On the other hand, it enables us to explain any issues to the customer. It also allows us to negotiate with the raw material manufacturers, while clarifying the situation. In the process of achieving ink-water balance, we also need to implement reasonable control over the printing equipment. For example, we can improve the wetting mechanism of the offset press, make it more conducive to achieving ink-water balance. For example, we have transformed the traditional oscillating dampening device into a continuous dampening device. At the same time, an intermediate roller is added between the dampening system and the inking system, quickly achieving water balance by the intermediate roller. To achieve ink-water balance more effectively and quickly, we need to choose offset printing equipment that is designed to be more advanced and reasonable to meet the various requirements of the printing production. Ink-water balance is a very important control point in offset printing. It is also a difficulty in the operation of offset printing. Therefore, we need to understand the meaning of ink-water balance, understand the various process parameters of ink-water balance, and control various aspects such as processes, materials, and equipment. Only then can we achieve ink-water balance in the offset printing process more effectively and quickly. The above is the main content of this course. Thank you very much.